Year 13, Chapter 10, Integration, Lesson 7, Harder Examples of Integration by Substitution. So in this lesson we're going to look at 4 examples of integrals which involve integration by substitution, all of which are a little bit trickier than the examples we have seen previously. Let's take a look at the first question. So I'm going to choose u, my substitution, to be 3x plus 4. And let's differentiate. Du by dx is equal to 3. Now let's do the sort of faux rearrangement that we're used to doing as a quick step. Now, you may have spotted something. There is another x in this question here, but there's no x to cancel with it in a minute. So let's see what happens. So, as always, I like to leave that x in place until we know anything further. So we have x over u, and then we have here du over 3. So no cancellation of the x. We cannot do this integral, however, as it stands, because we've got a mixture of variables x and u. So we've got to do something about the fact that the x does not cancel in this example, and that's because the denominator function 3x plus 4 differentiates to 3, which is not a multiple of x. So here is what we are going to do. I am going to take this u equals 3x plus 4 and I'm going to rearrange it to the format x equals u minus 4 over 3, and then what I can do is replace x with what it is in terms of u. So the whole integral will then just be in terms of u. Let's have a go at this. We'll just clear a little bit of space for us to do this, and let's try it. So we have the integral of, I'm going to pull that factor of a third out at the front. I'm going to write the u in the denominator as a 1 over u. And then where we've got that red x, I'm going to replace that with u minus 4 over 3. I'm being very careful as I do this because it's really easy to get very mixed up about what's in the denominator, what's in the numerator, which term is being multiplied by which other term. And if you just separate everything out like this, it's much better than having a fraction within a fraction in the numerator, for instance. So writing it all out as neatly as possible. Now, there is a product of a third and a third, so that can become a ninth out at the front. So we then have the integral of u minus 4 over u. And you might be asking yourself, well, how is that any simpler? It's much simpler because both parts of the numerator can then be divided by u. So u divided by u just gives me 1. And then, of course, for the second part, we've got a 4 here, which just becomes 4 over u. We can then integrate this very carefully so that we get x, and then for the next part we just get 4 ln mod u, and of course there's a plus constant at the end. So all that remains to be done is to replace u with 3x plus 4, and then we are finished. So we get 1/9 x minus 4/9 ln mod 3x plus 4 plus a constant. So the key part here was to use the original substitution to replace x entirely. And at this stage here, divide each term in the numerator by u so that you end up with single terms that can be integrated easily. Let's take a look at another similar example. So I'm going to say let u equal x plus 1, and notice again when we differentiate that, all we're going to get here is this. Nothing that contains an x. So this x here in the question is simply not going to cancel. So let's write out the integral. We've got x, and then I've got u to the power of a half, and then the whole thing is being integrated with respect to u. So I need to express this x part here in terms of u. So let me do that. If I go back to here, u equals x plus 1, x is equal to u minus 1. And we can make use of that in the integral. So again, let's create a bit of space for this. So this then becomes the integral, and instead of x, I'm going to write u minus 1. I've then got to multiply by u to the half and then integrate with respect to u. So now that the integral is all in terms of u, all I need to do is expand this bracket here and multiply both terms by u to the power of half. So what does my integral become? The integral of, and we're going to get u to the 1 multiplied by u to the half, add the powers, u to the 3 over 2, and then u to the half multiplied by 1 is just u to the half, all integrated with respect to u. So raise the powers by 1, divide by the new power. Now dividing by 5 over 2 is the same as multiplying by 2/5, and then over here, raise the power to 3 over 2, dividing by 3 over 2 is the same as multiplying by 2/3, plus the constant at the end. Now, it remains for us to replace u with x plus 1. So we've got 2/3 x plus 1 to the 5 over 2 minus 2/3 x plus 1 to the 3 over 2, and then don't forget plus c at the end. Now, we can factorise this. What can we take out? Well, look at the numerical constants here, the multiplicative terms here. Now, there is a 2 in the numerator, which will very easily come out, but we need to make sure we take out a common factor of 5 and 3 in the denominator. So we're going to have to take out 2 over 15. Now, we then take out the lower of the two powers here, which is 3 over 2. And then we simply need to think about what would be in the brackets here, so that when we multiply back, everything is as it should be. So to get 2/5, when we multiply by 2/15, I need a factor of 3 here. Remember, we need integers as multiples inside the bracket here. So the 3 would cancel with a 3 in the denominator of 15 and leave you with a 5 in that denominator, so you'd get 2/5. So we've got 3, and then it's got to be x plus 1 to the 1, so that 1 plus 3 over 2 will give you the 5 over 2. We then need to make sure we get 2/3 when we multiply, and we'll do that if we have a 5 in this second part here. 5 multiplied by 2/15 gives you 2/3, and then we don't need anything else because we've got the x plus 1 to the power of a third that we already need. So this then simplifies to give me 2/15 x plus 1 to the 3 over 2, and then the part inside the bracket here simplifies to give me 3x minus 2. And we have finished. So this part here is all about factorization, which you will remember from the topic on the product rule and the differentiation work that we've done. So by now you will have an inkling of how these examples will pan out in every case. And again, you should be able to see when we choose u equals 2 minus x that the derivative of this is not going to create any form of cancellation that we need. So all we have is this. So let's put our integral together. Now this x here, I want to write it as an x there until we deal with it. And this is going to be over the square root of u instead of 2 minus x. And then in place of dx, of course, we want this. And in fact, what I'll do is I'll pull the negative sign straight away outside of the integral there, so we don't have to worry about it any further. So what next? We need to make sure that we replace this x with what it is in terms of u. So of course we need to go back to this result here, and of course x is equal to 2 minus u, and we can use that to help us. So making some space again so that my working is really clear, this then becomes the integral, negative sign in front. In place of the x, I've got 2 minus u all over. Now, instead of the square root of u, I'm going to write that as u to the power of a half, and then this is with respect to u. Now, I need to divide both parts of the numerator by u to the power of a half, so that I get two single separate terms. Let's do that. So, remember there's a negative sign in front of the integral. My first part is going to be 2 over u to the power of a half, and the second part, well, I've got u to the 1 divided by u to the half, so that gives me u to the half. Now, I probably also want to rewrite that first term as 2u to the negative a half, as we do our integral. So this is going to give me 2u to the power of a half, but I'm dividing by the new power of a half, which means multiplying by 2. And then over here, we're going to get u to the 3 over 2, and of course that means multiplying by 2/3, rather than writing out divide by 3 over 2. And let's simplify this a little bit. We get minus 4u to the half plus 2/3 u to the 3 over 2. So let's continue with this. Now it's important that we rewrite this in terms of x, so we want to replace u in both cases by 2 minus x. So we get minus 4, 2 minus x to the power of a half, plus 2/3, 2 minus x to the power of 3 over 2, and of course there's this plus constant that we have to deal with. Now, let's look at the numerical constants, the multipliers here. I'm going to write that as minus 4 over 1 because it makes it a lot easier to decide what the common factor is that needs to be pulled outside of the brackets. It's got to be something that's a multiple of 1 and 3, so that's going to be a third. So I'm going to pull a third outside of the brackets. Now, I then want the lower of the two powers here, which is a half. And then I just build the insides of my brackets. So here, we're going to need to get negative 4, so that means that this has got to be negative 12, because that's the only way you can multiply by a third to get negative 4. I then don't need anything else, but for the next part, I need to make 2/3, so that means that I need a factor of 2 here. I then need to make sure I get to a power of 3 over 2, so that means I need 2 minus x to the power of 1, because 1 add a half gives me the 3 over 2 that I need. So when I multiply these together, the powers add to give me 3 over 2. Now, from here, let's simplify. And inside the brackets, we are going to find that we get negative 8 minus 2x, which all looks rather unpleasant inside the bracket. So what I'm going to do is I'm actually going to factorise negative 2 from this. So I've got negative 2/3, 2 minus x to the power of a half, and this part here, we've taken a factor of negative 2 out of this, so that leaves us with 4 plus x. And of course you can check by multiplying back that you get down to this result here. And then we've got plus c at the end. Now, let's look at this example here. I'm going to let u equal 1 minus e to the power of x. So du by dx equals negative e to the x. And let's see what happens as we substitute in. So, my numerator I'm going to keep as 1 plus e to the x until further notice that I can do something with that. The denominator is now expressed as u, and we then have this. Notice no cancellation here at all, and we've got lots of terms that feature e to the x, which we need to then deal with. So how can I do that? Well, let's go back to the fact that u is equal to 1 minus e to the x, so e to the x is 1 minus u. Now, from there, let's substitute in for the numerator. So we've got 1 plus 1 minus u in the numerator. And in the denominator, we've still got this u. There's a negative sign that I'm going to pull out to the front. And then I'm going to have to do something about this e to the x as well. So I'm going to replace that with 1 minus u. So what does my integral then become? It's starting to look a bit messy. I've got negative 2 minus u over u, 1 minus u, with respect to u. Now I'm going to tidy this up a little bit by incorporating this negative here into the numerator. So it becomes u minus 2, which is a little bit easier. And then we find ourselves having to use partial fractions. We've got to decompose this into its constituent partial fractions before we can integrate. So let's take what we have, u minus 2 over u, 1 minus u, and let's express that as a over u plus b over 1 minus u. So this then gives us u minus 2, a is equivalent to, remember, we would be giving these the same common denominator and then equating the numerators once the denominators are equivalent. Now this is a very simple pair of partial fractions. I'm going to choose u equals 0, which gives me negative 2 equals a, and then I'm going to choose u equals 1, which gives me negative 1 equals b. So this then tells me that u minus 2 over u, 1 minus u, can be expressed as negative 2 over u minus 1 over 1 minus u. And I'm just going to tidy that up again by dealing with this here, incorporate the negative in, and we can rewrite that as 1 over u minus 1. And this will make the integration that little bit easier. So here is the result. We've got to do the integral of both of these parts here. So this is going to give me ln mod u minus 1, and here I'm going to simply get minus 2 ln mod u plus a constant of integration at the end. And then let's remind ourselves of what u actually is in terms of x. U is equal to 1 minus e to the x, so this gives me ln of 1 minus e to the x minus 1, modulus of, minus 2 ln mod 1 minus e to the x plus a constant. So this then gives me, for the green part, ln mod negative e to the x. Now that's really interesting because e to the x is always greater than 0. So that tells me that negative e to the x will always be negative. So when we take the modulus, this is going to give me ln of e to the x. And I know that that is simply equal to x. So I get x minus 2 ln 1 minus e to the x.